So using Taylor expansion, expand sine pi over 6 plus h. So the first step in this calculation or this solution, you have to determine your function of x and your small change. What to know in Taylor series? Taylor series is the application, just an application of small change. So there's a small change h added to pi over 6 to make it a certain value. So when you have been asked to expand that one, then you have to let your function of x be sine pi over 6. Then come and determine your small change h. Your small change h should also be in terms of sine, which is sine of this h. What will be there, which is sine of h. This is small change. So leave alone with this one first. We know for any function of x, for Taylor series, for any function of x, we just take f(x), the function of x, we add to f prime of x, we multiply by h. Then we add to h, the series keeps on, this is h raised to power 0. The series of that small change h keeps on increasing. So h squared, then f double prime of x all over 2 factorial. This should be over 1 factorial. This is over 0, the power factorial. And you are continuing. So for any function of x given, you have to apply this series. There's a series. This is what we know as the Taylor series. Now, we have determined our function of x be sine of pi over 6. Therefore, if the function of x, already we have it as sine of pi over 6, we have to find the second derivative. We need second derivative, third, the first, third, second, and third derivatives. As per question normally asks for the third derivative. So let's find the first derivative of this function. So when you differentiate sine, just give you cos of that angle. When you differentiate cos, the second derivative of x, it will just be minus of sine of that angle. The fourth or the third derivative, not the fourth derivative, it will be sine won't change. When you differentiate cos, it changes the sign, but when you differentiate sine, it doesn't change the sign. The sign remains negative, but turns cos pi over 6. So we have up to the third derivative. Let's come and apply it in our question. So our function of x is given by a. So applying that, so it will be sine of what? Pi over 6. That is our function, our original function as indicated there. So plus h, the small change. When you apply, when we want to expand a such function, you just say just the function of x, which is sine of pi over 6, then plus h multiplied by, can't you see h multiplied by this? Just substitute what you have here. So cos of pi over h. Then we have to add h cubed of h, not h cubed but squared of what? The third derivative, the second derivative. So the second derivative, we have it here, which multiplied by minus sine pi over 6 all over, but this should be over 2 factorial as indicated in the series. Then finally we have to go up to the term h equals to power 3, and that is enough for Taylor series. So multiply by minus cos pi over 6. So the third derivative is this one. So just multiply as indicated in the formula normally. So all over 3 factorial. So we are done with, now for there up to there we are done with the expansion. So they're asking you now, hence evaluate the sine of 45. I will show you the easiest method of solving it. Remember, we have these three angles, 30 degrees, 45 degrees, and 60 degrees. These angles, they are specific. They are very specific. So we choose an angle. Since this is sine 45, we can't use 45 because there's no any change. We choose an angle that is much closer to our angle that will have a change. So, for example, let's say, so for this function, sine of 45 degrees is the same as we write it. Use an angle but which is closer to this angle, but not that angle. You can't use 45, there'll be no any change. This is like writing it sine of 30 degrees, then you add 15 degrees. So our small change h now, let's determine now our function here was sine of that angle. Sine angle now, so it will be sine of 30. Our fx now, our function, it will be sine of 30, and our small change h, it will be just the sine of 15 degrees, as we showed it before. You also break that function in this form. You say, let this one be the function of x, this to be the small change h. So for small change h, just key in sine of that, and also key in sine of this one, so that this one be the function, the function of x, and this one be the smallest, the small change. So I'm gonna tell you why we use these angles. They are so simple than substituting with any other angles. Very simple to evaluate. Why? When you key in sine 30, you need also to key in cos, tan, maybe tangent, and other. But what if we use these angles? So angle of, assuming this is 1, 1, an equilateral triangle, here to be 2, here it will be 2. These angles are 60, this is 30, and this is 60 degrees. So this height here is always root of 3. Using theorem, we get there is 3. Now, what is our sine of that? We can say for sine 30 degrees, which is the same as sine of pi over 6. So we had to use this expansion here to evaluate this, our new function, as we have written it here. Can't you see that small change? So we have to apply that one too. So this one is like pi, the theta now here is pi over 6. So for pi over 6 is the same as that. So we just say sine of that is just opposite over adjacent, which is a half. Leave alone with that one. Let's find cos. We can see that in our function we have sine, we have cos, we have sine, cos. So let's just find cos of 30 degrees. So cos of 30 degrees is just what? Cos just adjacent over hypotenuse. So equals root 3 over 2. So let's go back to our, but we can key in. So small change is sine of 15. We can't get sine of 15 here. We just key in sine of 15 degrees, which equals to a value. So that value, sine of 15. So keying in sine of 15, you get 0.65. That's sine of 15. So a point of correction, the sine of 15 is 0.2588. Set your calc in degrees, not in radians, since our angles are in degrees. Then why do we let this h be sine of a number that is you can't obtain it here? Is because it is common. But for this function of x, it keeps on varying cos to sine, sine. So it's simple for we to use it as it is. So let's go back to our function of x. Now let's use this function to determine the sine of 30 or sine of 45. So sine of 45, our function now here is sine. Our sine of 45 degree, it will be, you take the function of x sine pi over 6 sine 30, sine theta is a half. So, and cos theta is root 3 over 2. So just substitute. So sine of this it will be a half. This it will be h multiplied by root 3 all over 2. This one it will be just h cubed multiplied by minus a half. Then this one it will be h cubed multiplied by what? Minus root 3 over 2. Let's come and substitute them here. So it will be just a half plus h root 3 over 2 plus h squared into minus a half plus h cubed into minus root 3 over 2. Then can't you see now it has become simpler. So let's substitute the value of h. Value of h is this one. So it will be just sine. So the value of h is here. Just let's substitute sine of 45 degrees to be just a half plus h into root 3. So h, our h, we have it there. So just 0.2588 root 3 over 2. So plus h is 0.2588. Then multiplied by what? We multiply by a half minus a half. But this one here is should be squared as indicated here. Then h cubed. So plus h cubed. H cubed is 0.2588. Then we cube, then multiply by h, what? H multiplied by minus root 3 over 2. So using your calculator, therefore our sine 45, it can be obtained by using that expression. That expression there. So we just take a half, which is 0.5, just key 0.5 plus, open your brackets, 0.2588, 288. We just multiplied, open your brackets, the root of 3. So key root 3 all over 2. Close your brackets. Then plus, you have to plus 0.2588 squared multiplied by what? Open your bracket there, minus 0.5. I have the same as 0.5. Then plus, you can open also your brackets or leave it as they are, 0.2588 cubed. Then open your brackets, multiply by minus root 3 over 2. Then key in equals sign. So sine 45 is equals to 0.7. So let's shift. So which equals to 0.762. Okay, so therefore this is your answer for sine 45 using Taylor series. So Taylor series is the application, just an application for this. You expand, then you can find any angle using a certain using the small change. You can find the result for any sine of angle, any angle you want. So when you key in sine of 45, you may end up with a result like that, because now this has to continue. There's a lot of other values that we have ignored them. That's why our answer should have a very small difference, but not too large. That's just an estimation. So when my videos, you benefit from my videos, so just subscribe for me also, so that we can all benefit from it. So I need also to benefit from that. Just subscribe. It costs nothing. It costs you nothing. Just a microsecond. Just tap the subscribe. There's subscribe there. Just tap it. Subscribe. It costs you nothing. Na kukosti ni ukivinja hiyo. So naachia watu wa nani wafanye mambo yao, watu wa huko. So
watu wa unga ama umesema
watu wa YouTube. Sasa siweni subscribe.
Wa unga.
Sasa man, nasoma mtihani leo. Tumesema plate electro. Unga hii. Jana nilikuwa nisome unit fulani, so